Hello, welcome back. This is 5-1. We are talking optimization, maximization, and minimization of story problems, word problems. In this video, we are going to look at the second example, which will focus on a minimization problem. And we'll use that same procedure that we talked about in the last video for this one. So without further ado, we'll go ahead and get right to it. Number 2, the product of two positive numbers is 288. Find the two numbers so that the sum of twice the first plus the second is as small as possible. Okay. Well, first of all, we need to define our numbers. The product of two positive numbers. I don't know what they are. I'm going to call them x, and I'm going to call them y. And what we know is that the product of these two numbers, x times y, is we know that that is 288. Okay, so there's the information that is given. And step number 2, it says choose a primary equation. Okay, and what you have to do is you have to take the equation that you're wanting to minimize or maximize or optimize. Okay, and in this case, it is the second piece here. It says find the two numbers so that the sum of twice the first, okay, plus the second is as small as possible. Okay, so I'm going to take the sum of these two numbers, don't know what it is. Okay, and I want that sum of 2 times the first number plus the second number. And I want this to be as small as possible. I want to minimize. Okay, so we're looking for minimization. So, step 3, it says rewrite with only one variable on each side. This may require a second equation. Well, I have an isolated variable here, which is y. And so what I'm going to do is I'm just going to rewrite y as 288 over x. And then I'll substitute. So this gives us s is equal to 2x plus 288 over x. Okay, so now all I have is one equation, and what I'll do is I will rewrite this to be 2x plus 288x to the power of -1. Now I'm doing this because step 5, when we take the derivative, we'll easily use the power rule. But first, what I want to do, so this is step 3, I rewrote with one variable. Step 4, I want to talk about domain. Step 4, domain. So domain, I know that these numbers have to be positive. I know that x and y are both going to be greater than 0. But I know that their product is 288. Okay, so I know that the biggest these numbers could be is 288. The smallest they could be is 1. Right? So 288 times 1, those are the factors. Okay, and then everywhere in between. Okay, so we want those numbers we want to minimize. Okay, how do you minimize? Well, you got to take the derivative. So what I'm going to do here, I'm going to take the derivative s prime, and s. If I take the derivative of s, notice that's a sum, right? That's a whole value. Okay, so that's going to be equal to 0. Okay, the summation. Or actually, sorry, s prime is equal to 2 minus 288 x to the power of -2. And what we want is, I want this to be 0. I want to find the critical numbers. Okay, where is this equal to 0? Okay, so now I'll solve. So what I'm going to do is I'll move 288 over to the other side. 2 is equal to 288 over x squared. Now I will cross multiply. 2x squared is equal to 2. Whoa, the lights went out. See what craziness I have to deal with, okay? We get x squared is equal to 144. Thus, x is equal to plus or minus 12. Now, again, we said our domain, x and y, must be positive, okay, between 0 and 288. So, yeah. Okay, so it's got to be 12. Can't be -12. All right, so I want to know, okay, 12 is a critical value. So what I'm going to do is I have my number line here. I have my endpoints, 0 over here, 288, and then we have 12. Okay, and I want to know, is this a max? Is this a min? Where are my max and my mins going to live? Generally, when you only get one critical value, that's going to be your max or your min, right? If I had other critical values, I would test and see. So we'll test. We'll go ahead and plug in some values into our S prime. So let's test 1 is a good number. I'll plug in 1, okay? And where are we? Okay, so I plug in 1 into S prime here, and we get 2 minus 288 times, actually divided by 1, okay, and you get a negative. So our function is decreasing, okay, looking promising so far. And then I'm going to go ahead and I'm going to plug in a number, any number, okay. I'll pick 100. There's no real good number because what we're going to do, we got to plug it into 2 minus 288 over x squared. Now, when you do this for 100, you get approximately 1.97. Okay, that's positive. So that's increasing from 12 to 288. Okay, so what do we know? Hey, it's a minimum. It is a minimum. All right, we're in business. Well, I need y. I know that x is 12, and I know that y is equal to 288 over x, which is 12, and this gives us 24. I know x is 12. I know y is 24. We have minimized those two numbers. Thanks for watching. Catch you next time. Peace.